Good morning, my listeners. We want to talk about the derivative of gamma function. Now, if you look at this, you are going to see for you to derive a gamma function, you use what is called the Poisson distribution. Probability of error occurring is equal to lambda t raised to power r exponential minus lambda t all over r factorial is what is known as a Poisson distribution. And you know that Poisson distribution is a discrete distribution. We want to use that to obtain a gamma function. Now, if you consider this Poisson distribution, the event are occurring at the rate of lambda and at time t, and this occurs, you consider it occurring up to k minus 1 times. You now have, because it's a discrete distribution, you have summation of r running from 0 to k minus 1 equals r running from 0 to k minus 1 summation of lambda t raised to power r e raised to power minus lambda t all over r factorial. But if you want to consider for at least k events, meaning that it can be k and above, it then means that it runs to infinity. Here you have r equal to k to infinity equals 1 minus this distribution here. Now we make transformation. So let lambda t be equal to z and r equal to k minus 1. Substitute this and this into this function. What will you have? Anywhere you see lambda z, you put what? Lambda t, you put z. Anywhere you see r, you put what? K minus 1. You have this. In place of z, in place of lambda t, we have z. In place of r, we have k minus 1. E raised to power minus z over k minus 1 dz, which will now give us this. And this is what is called the gamma distribution.